Hello, in this video I'll show off the quick scatter system I made with geometry nodes. This video isn't scripted, so there will be a bunch of jump cuts and probably some rambling. When I was working on the quick scatter system, I wanted it to work with two workflows. One is using the modifier stack and the other is inside of the node editor. That means that there were some compromises in the design and there is also some wonky UI present. I'll explain more as we go along in the video. As you can see, I opened up the asset browser and I'm showing off the three scattering nodes and the two masking nodes. First I'll go over the scattering nodes and then later I will show off the masking nodes. The three scattering nodes are similar in terms of the settings. They're just scattering on different sources. So for instance, scatter on surface scatters instances on a surface, scatter on curve does it on a curve, and instance on element is scattering on individual elements. I'll go more into detail when I reach that. I will start with the scatter on surface. You can use the scattering like a modifier. If you just drop it down on the object, it will add the modifier, or you can have a geometry node set up already and put it inside of the geometry node like this. This does the same thing, just the UI is a bit different. I will be using the node editor UI because it's prettier. Before I even define which asset I want to scatter, there is already some visualization going on, as you can see here, and the node is throwing me an error, which is that no asset geometry is detected. I guess I should now go over the inputs. As you can see, the first one is the surface we want to scatter on. Then there's the selection where on that surface we want the scattering to happen. This is the coarse selection. Later on, you can also use this finer selection, which is a float instead of a straight boolean. Then the next setting is this output with surface, because sometimes you want to keep the surface that you're scattering on, and sometimes you don't want to do that. You can just toggle it and that's it. If you're stacking the nodes like this, then you have to be careful to actually, let me change the seed first. If you disable the surface in here, then this scattering won't happen because there's no surface to scatter on. So just keep that in mind. But if you disable it on the last node, then all the previous scattering happens. Let's continue to the asset definition. Here in the node editor, we have this option to either pick the data block or the geometry. The geometry input isn't available if you use the scatter on surface in the modifier, because we can't really define the geometry because it's a green socket, but you can define it with a data block. I will quickly just show how this looks in the UI. So for example, if we just add it like that. If you go in here, you can see that there isn't even this option. It's just hidden and set to the data block. For now, I will disable this and try to focus on the node editor view. You can either scatter an object or a collection of objects. So let me see if I have any objects prepared. For example, a tree, you can see. I'm scattering a single tree, or I can scatter a collection of trees. These are different trees, as you can see. Here are some smaller ones and here are some larger ones. Then the next option is realize instance depth. I need to prepare an example for this to explain it, so hold on a second. So here I have the example to explain the realize instance depth. As you can see, I have a collection named depth, which is a level 0, then a numbers collection, which is level 1, letters collection, which is level 1, and then even numbers, which is level 2, odd numbers, level 2, and for the letters, I don't have the level 2s. So, for example, if we're doing some scattering, I will disable this for now. What we can see at level 0 is we can see letters and numbers stacking on each other. So it's taking every object and scattering it on one point. If we go a level deeper, then we can see that the letters are separated from the numbers. So level 1, these are our two objects basically. Now we're scattering either numbers or letters, and because there is even one more level for the numbers are still stacked together. But if we go to level 2, then you will see that the numbers aren't stacking on each other anymore, but you can also see that there aren't any more letters present. If you go back to level 1, you can see a couple of A's and B's and C's, but if we go to the level 2, we don't see the letters anymore. So basically, this defines the instance depth and how it should be realized. You will usually use it at the default level, but just keep in mind what it does. So basically, if you have a collection inside of a collection, and for example, if you have a collection of trees, and then inside that there is a collection for, I don't know, tropical trees and more Arctic trees. If you don't want stacking, then you need to go a level lower, basically. I mean a level higher, I guess. Yeah. That's what this does. Now the next setting is the 2D billboard. This is basically when you have 2D assets. So for example, if I switch to the 2D trees collection, and it's based on the active camera, so I need to add a camera object, and if I enable the 2D billboard, boom, they should all, the trees should be facing me. Because they're so close, there's some intersections going on when they rotate, but yeah, so if you have an actual scene, they wouldn't be that close to each other. We'll discuss those settings later. So yeah, 2D billboard just makes the asset act as a 2D asset. To explain the reset transforms, which is the next setting, I will use these numbers and letters scene again. First, I will move the letters around. So for example, here is A, here is B, and here is C. I don't know why are there. Oh, we're supposed to look at it from this way. And then the numbers, for example, here, 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 and here. As we did that, we actually moved the objects from the origin point. So if we disable the reset transforms, they should all be shifted. For example, if I control the rotation setting, you can see that they're not rotating around the center, around their center. But if you do the reset transforms and randomize it, then you can see that they're basically centered. This is what the reset transform does. It basically, if we move the object, it moves it back to the origin before scattering. For the realize nested instances, I prepared another scene. This comes in handy when you have assets where you have a tree and the leaves are scattered on it. They're not actual geometry, but they are scattered on it. I made this setting specifically because I was using some polyhaven trees, and on those assets, the leaves aren't modeled, but they're scattered on, which is a good workflow. But when it comes to scattering a bunch of trees, it actually ruins the performance. So if we look at the performance when it's enabled, you can see it's smooth, but then if I uncheck it and move my camera around, you should be able to see the stuttering. Basically what it does internally is, let's see how this works. We have a tree with some leaf scattering. These are just some planes, but you can imagine that there are actual leaves. It basically applies this scattering internally, and that makes the performance a lot better. If I were to test the rendering speed for this, it would be very different from when I use the realize nested instances and when I don't. Also, I think I set up a material to show off. Okay, yeah. Here you can see how it works when I have realize nested instances turned on. Basically, each color is a individual object, and when I disable it, because of so many individual objects now, first of all, now you can really see that the scene is laggy. Yeah, and this is just me turning around. You can see that each leaf is an individual object, which makes the performance really bad. This setting does increase the memory, but it's worth it, and it's marginal. It's not. You would want this performance over this. And it's not just the viewport. Even when you go and render the scene, it takes like 10 minutes before you even start rendering. So that's what this option does. That covered the asset settings. Let's put this now to the regular trees and disable the to the billboard. Now we will go over the scattering options. First of all, you can see the density setting, which is basically how dense the points are on which then the assets get scattered. Then we have the factor. This is sort of like opacity. You can use this as a mask. You can use a noise texture and input it into the factor to define where you want the trees and where you don't want them. It's basically a more gradual transition then. If you use the selection, you have a boolean, which is either there are trees or there aren't, and when you use the factor, it's either there are no trees, there's a 50% there might be a tree, and there are definitely trees. Then the minimum distance is basically how far apart each tree should be from each other. All of these settings are taken from the distribute on surface, I think. Distribute points on faces. These are the same settings basically. And then there's the seed. This output name is useful when, for example, let's make a scene, trees A, and then we use another scatter on surface. Let's use a different seed. This would be trees B. Let's say we want a bit less of those. Now, if you want to have a material on trees A and a material on trees B, you can define the different materials. So as you can see in the spreadsheet, if we select this object, you should now see the instances. Yeah, you can see these trees belong to trees A and these trees belong to the trees B. You can use that in the shader editor to make some cool masks. For the boundary fall-off, I will use another pre-prepared scene. In this scene, I'll show off the boundary fall-off. Here I have an example of a walkway, and I want to avoid this intersection of the grass with the path. The usual solution to this is to just move the surface a bit, so move it like that, but that's annoying to do. So what I have done instead, I created an edge mask. If you check it out in the weight pane, you can see I have masked this edge. And now if I enable the grass again, and if I enable the actual boundary fall off, you can see that if I move this distance, it removes it creates a gradient, and based on the distance in that gradient, it removes the scattered points. This fall off type can be constant, so just a sharp edge. It can be a gradient, so you can see we have a start and an end. Yeah, or so this is useful when you have a road with dead grass, where at the edges it's usually a bit more sparse and then later on it gets more full. You can also use the absolute or relative scaling. So for example, I want the grass to start appearing at 20 centimeters. This is how you would set it. Or if you don't want to do it by actual distance, you can do it relative to the mesh size. So for example, it goes from here to there and then remaps it from 0 to 1. Besides of actually culling the assets, you can also just store this information as an attribute. So here all the scattered objects are back, but this is now stored in the QS, which stands for a quick scatter, boundary falloff attribute. You can use that either later with your own geometry nodes or inside of the shader editor. The remove intersecting option is a bit experimental, but basically what it does is after scattering, so let's say I spawned a bunch of trees, I want to remove intersections. You can do that with minimum distance, but if you have trees with different scales, this option might work better for you. So basically you just enable it, then ramp up the iterations and how certain you are that you want to remove the object. So yeah, these are too many iterations, I guess, or the weight is too strong because it basically removes every tree. If we scale up this, then there is less possibility of intersections, which means that there will also be a lot more trees. Then if we increase the density a bit more, it's a bit wonky, but it does sometimes come in handy. For example, if I lower this threshold a bit, it gives me better results. It's useful when you have small and big trees, and because when you have big trees, they take up a lot of space, but if you also want small trees that are dense, you basically have to overscatter the assets and then delete the intersecting ones. I'll show it in another example. So here is the example with a forest. I just turned on some optimization so you can see better what's going on. Here we have the big trees and here we have the tiny trees. I think that in nature the growing happens like this, where you basically have a bunch of small trees scattered together, then not all of them make it, only a few of them, which then relaxes the spacing a bit more again. So if we remove the intersecting, you can see that there's a lot of big trees intersecting, which is not really correct, I think. So we can use the remove intersecting, which still keeps most of the smaller trees, so they're dense, but it adds some gaps to the larger trees. This option is a bit experimental. I might change it in the future, but it comes in handy. The post-processing option is only available inside of the node editor. If we look inside of this object that I created before at the start and we go under the scatter menu, we can see that there's remove intersecting, and there's no post-processing below it. That's because the post-processing just uses closures and those aren't supported in the modifier view. So basically what this does is, let me spawn a bit more trees and let me scale this up a bit. Also, I'll remove the camera because it's annoying me. So if we add a closure and connect it, now if we look at this output, we can see the points that are used to scatter the actual trees. So we can basically influence the scattering before the instancing happens. So we can, let's say, use a set position and offset everything in the z-axis. I guess you would do something more elaborate than that, but if we now look at the output, all of the trees are moved up. You can also use, for example, delete geometry and then maybe do a random value, set it to Boolean, and then you have some random deletion. You have most of these settings already inside of the node, but for some use cases this closure comes in handy, especially because you also get the source input, which means that you can also use it if you want to store some attributes. So maybe you want to store some specific attributes that come from the surface where you did the scattering. So in that case you would use the sample nearest surface or that other one, whichever. Yeah, you would do that. You would define which attribute you want to actually sample, And this is the use case. You would use this, but it's not that useful, but sometimes you need it. So that's why it's there. Then you can just disable it. For the asset order and the scatter order, I will again go to the example scene. So in this scene, we have a collection of shapes. As you can see here, we have a Suzanne, an icosphere, and a cuboid. I will be using these shapes to explain the asset order and the scatter order. The asset order is how the system first orders the assets before they are scattered, and the scatter order is basically defining which asset should go where. So let's look at that on an actual example. I have some surface scattering here going on, and I will disable the overlays. I have a curve object. This is creating a gradient. As you can see here, it's 1 and here it is 0, and based on that I'm defining which assets I want where. I will disable the curve for now, and I'll keep this visualization. Let's start with the asset order. As you can see here, we go in the order of the names of the shapes. I will move them up so they're not obstructing the view. We can either order the assets alphabetically, so here we can see cuboid, then icosphere, then Suzanne. We can also invert this, so it's the other way around, which feels more correct. So for example, if I want this to be the last one after the Suzanne here on the edge, let's rename it to Zeboid, I guess, but nothing changed. I think that this is a bug. If we just pull this out and pull it back in, now you can see that it actually updated. I don't know if it's a dependency error or something, but yeah. So basically, this is how you can define the order using the names. This is the default options. Then we have the size option. Let's start with Z, I guess. So if you look at this, we can see that cuboid is the tallest object, then it's the icosphere, and then it's the Suzanne. So we can also see this here. First the cuboid, then the icosphere, then the Suzanne. If we look at it from the X and Y view, we can, I'm not really sure, I guess, yeah, this is the smallest object, then it's this one somehow, and then this one. This doesn't look correct to me, but okay. Yeah, I think that it's just because of the internal logic that this fails here, but yeah, it should work like that. Then if you look at all three of the axes, we can again see that cuboid is the largest, then the icosphere, and then at last the Suzanne. Again, we can invert this. The last option is to use the integer attribute. On these assets, I added a custom geometry node, which basically just sets an attribute called custom index to a value I define here. So you can see Suzanne has 1, icosphere has 0, and cuboid has 2. And in here, I basically just select the custom index attribute. I can again invert it. And then, for example, I want these two to change their order. I will basically set the icosphere to 1 and Suzanne to 0, and now the order is changed. This was how we set up the order of the scattering, or the order of the assets. Now here comes the scatter order, which is actually how we want to scatter these assets. The default value is random, which just randomly scatters the asset. Then we have the float attribute, which is using this mask, which is generated by the proximity mask geometry node, to tell the assets to basically use this gradient to swap between the assets. One thing I want to point out is that by default it goes to 0, but if you type in -1, then you can see that these lines between the different assets become more clear. And the higher, so let's set it to 0, and the higher that the value is, the more dithering happens inside of this gradient. So for example, imagine that these are actually trees. You have some big trees, some medium trees, and some small trees. If you're doing scattering, you obviously don't want a clear line like this, but you want some some dithering. So if we set it to, let's say, 0.6 or 60%, it basically enables the medium trees to move inside of the large trees and inside of the small trees, and the small trees to expand more into the medium region, and large trees to expand more into the small region. So basically it just moves the assets around. This is important because if you have a forest scene, you actually want to have large trees assets and small trees assets. You don't want to just scale down the large trees to be small, because that's not realistic, because they are actually a different shape. This is where this option comes in handy, to basically just use a gradient where at the border of the tree line you want the smaller trees, and in the middle of the forest you want the large trees. There's also the integer attribute, but I don't have that attribute actually on the surface, so I can't use it. But I can show off that if I set this to 1, then it only uses the shapes, then it only uses the icosphere object, and if I put it to 2, then it only uses the cuboid object. So that's it for the asset order and the scatter order. The next option or sub panel is the auxiliary surface, which is basically just a shrink wrap. I will use this walkway scene to explain the auxiliary surface. If we enable it, you can see that the scattered grass actually snapped to the grass object. The naming is a bit weird, but basically this is the grass and this is the circle geometry. We can either use the object or a collection. There is also the other data type, but since I'm showing this off in the modifier, you can't see that. We can define the object. We want the snapping to use. Then we can also use this selection to define which part of the object we want to use for the snapping. So for example, here I made a mask called surface group. And if I go into this selection and select the attribute toggle and select the correct mask, I have to type it because it's not stored on this geometry but on the surface geometry. So I have to just type surface group, I think. Yeah, now you can see that the snapping only happens on here, and you can also see this weird line that happens because when we use the proximity mode, it just snaps everything to the surface no matter the direction. And if we switch to raycast, you can see that now it uses the normal direction of the surface and only snaps these two circles, or basically this circle and like 3/4 of this circle. We can set it to only affect positive direction or only negative. In this case, if we move it down, only this one gets influenced, and for now let's disable this. And if we use it only positive, only this one snap, and if we use both, then all of them snap. There's also this max distance. If you see here, let's move this and this a bit higher. If we lower this distance, you can see that only those inside of this distance get snapped, yeah, and the others get ignored. But the auxiliary surface doesn't only snap the scattered assets, it also either transfers rotation. For example, if this were rotated like this, let's also increase this. You can see that the grass is pointing up, but if we also align the rotation, then we can also reorient the grass, or we can also sample the UV map. Oops, I meant this, yeah, the UV map. These settings are a bit limited for now, but I think they'll have to stay like this for a while before we get new features inside of Geometry Nodes. So for now, there's only an option to sample one UV map. You can sample more attributes if you use this node inside of the node editor and not in the modifier stack. Like you can see here, there's also this custom attribute subpanel, which is using a closure, which you can only use inside of the node editor. Also here you can see that we are actually also have a geometry input, but since I was showing it off inside of the modifier context, it didn't show up. Let's move on to the rotation settings. They're quite self-explanatory. Each asset by default gets the rotation randomized around the z-axis, and you have no control over it yet. In the future I will probably add that control, but for now the randomize only influences the other two axes. So if we ramp it up to 1, you can see that the trees tilt so much that they basically touch the ground. A realistic setting is around 0.1 probably. You can also control the seed of the rotation. The 2D billboard tilt is meant to be used with actual 2D assets. So if we set this to 2D billboard and we pick 2D trees and go into the camera view, if we set this to 0, we will see that the alignment to the camera only works around the z-axis, kind of, but if we tilt the camera, you can see that the trees are still looking at the camera direction, but not totally. They're not tilting, but if we push the 2D billboard tilt all the way to the 1, you can see if I look at them from the top, they follow the camera even in that direction. I didn't know which is the correct behavior. This is why I added this slider. The default is at 0.1 because I think that's good enough. Also, when it comes to 2D assets, the randomize still works, but it might look a bit funky. As you can see, they are randomized only around this axis. I don't know which axis this is. I guess the camera z-axis. Yeah. Let's go back to the regular trees. Okay, so the align to direction is the next option, which is under the rotation. If we rotate this object like this, and if we set the object space to global, we can see that, and if we ramp this to 1, we can see that all of the trees are pointing up, because the default for this direction is with the value of z1. So this is useful when you have mountains. The trees, when they are on a slope like this, don't align themselves with the normal, but they actually look up away from the earth into the sky. They're pointed into the sky. With this, you can basically control how much they're pointed at the sky, or actually how much they're pointed at the specific direction. If I actually use the vector constant and I put it into like z, then they're all pointed into the z. But the default behavior usually is that you want the trees to point up. So yeah, that's the default. Then this local and global just switches if we rotate this object inside of the local space. You can see that the trees follow the sky, but if we rotate it in object space, let's disable this for now, you can see that the trees are still pointing in the object space z up. But if we set this to global, then that rotation gets ignored and they're always pointing up. So that's it for the align to direction option. Here we are back again in the walkway scene, where I will show off the boundary alignment setting. Let's say that I want the grass at this edge to flow over this walkway, and let's say that the walkway is actually positioned like this. Usually this is how grass works. It doesn't point straight up at the edges, but it overflows. So to do that effect, we can basically just enable the boundary alignment. By default, it uses all of the boundary edges. We don't want that. We only want this boundary edge, and we already have a mask for it. So let's just switch it to the attribute mode. Now you can see that all of the grass clumps are aligned towards the edge, but actually the closer they are, the more they are aligned. We can use either the absolute option or the relative option. So this is a percentage and this is an actual distance like before inside. It's basically the same settings that we have in the boundary follow. But what I want to do is to limit this to only the ending part, let's say to 10 centimeters, and let's set the amount a bit lower like this. So now we can see if I disable and enable it, there's some overflowing going on. And that's cool if we wanted that effect. I can, let's say, disable this attribute mask. Now this effect happens at all of the edges. We can also invert the direction. So for example, let's put this mask on. If we put this pathway back here, let's say we want the grass to point away from this pathway. This is how we would do it. We would just enable this invert direction. Yeah, so now, for example, here at the edge, we don't want the intersections. We can just tilt the scattered assets away from this edge. Inside of the scale sub-panel, the settings are again pretty self-explanatory. I'll just quickly go over them. The first option is to adjust the size of the asset. Sometimes we have the wrong size for the asset. So for example, I can decrease it or increase it. This is for randomizing the asset scale. I wouldn't go too overboard with this. I would stick around this 0.25 value. Then there's the reflect setting, which basically just mirrors the asset. It's under scaling because it's basically the same thing that happens when you do scale around x and -1. It's doing this operation, but on each asset, and it's doing it on the x-axis and on the y-axis. This just gives you even a bit more randomization in your assets. Then there's the seed option. The boundary scale is again similar to the other boundary settings. Here I'll show it in this scene. I will just make a few more trees. If I enable it, you can see that it uses by default all of the boundaries. Here I could pipe in a specific boundary edge, but I won't. I will be using all of the edges. You can use either absolute distance definition or relative distance definition. For example, here you can really see the difference. When it's set to relative, here it's 1 and here is the 0 value, I think, or inverted. And if we use the absolute, it only goes 1 meter away from the edge. Let's use the relative in this case. We can define this distance a bit more, and we can also then set what the maximum size is at 1, so here, and what the minimum size is at here. I guess that you could also flip them around if you wanted to. So if you set this to 1 and this to 0, it gets flipped. But usually you would just want to, I don't know, set this to half and this to 1. And that's it for the boundary scale and scale options. The last panel is the optimize node panel with the active camera cull sub-panel and the viewport proxy sub-panel. So let's go over them. The active camera cull is basically for culling the scattered assets using your camera. So let's add a camera to the scene and let's look through it. Let's position it a bit better. And if I zoom out a bit and if I enable this option, you can see that only the scattered assets that are inside of the camera view are being scattered. If I move around, you can see that they are being deleted and added in real time. There are some margin settings. So for example, when you're in this kind of view, you usually want a bit more trees in the Y direction, like this. And sometimes you also want to add some margin on the left and the right side of the camera, which is what the X bounce margin is used for. So here you just basically add a bit more padding to prevent any shadow glitches or something like that. And the the last option here, or not actually the last, but the last float option is this origin margin. It's best explained if we look at it outside of the camera view. So for example, we can see that there are only trees here at the distance, but no trees here around the camera. So if we had a scene where the camera was down low like this and it was pointing up like this, we can see that there are no trees making the shade around the camera. For that, we would want to basically enable this origin margin, which creates a circle around the camera. So if you look at it from here now, without it, the scene would look like this, and with it, it would look like this, which is more correct for the scene. We would expand this more and a bit more. Okay, so yeah, now if we look around in the camera view, it looks correct, even though there is still culling going on. Let's reset this. There are cases where we don't want to cull the scattered assets, or at least not all of them. For example, I had a scene once where I had to do vegetation for a house render, and I wanted camera culling to increase the performance, but I also wanted the scattered trees to still exist in the reflections of the windows. So for example, let's imagine we have a house in front of our camera. If there are windows on that house, we won't see any trees behind the camera. So in this example, we actually want to subdivide the mesh a bit. And let's say we want these trees here. So we will select this, add the vertex group and assign it. And then I would basically just feed in a named attribute if we're working in the node space, group and connect it. And now we can see that even though I'm not looking in that direction, there are still trees behind me. This option is really handy in some cases. So that's that for the active camera call. Now let's continue to the viewport proxy. If you have really large scenes and heavy assets, you don't want to actually display those assets while you're working in the viewport. You want to use some proxies. And by default, when you enable viewport proxy, it replaces those assets with points. You can control the amount of scattered assets in the viewport. For example, if you're working with grass, you actually don't need to see all of that grass. You can tone it down to just 20% of the grass, for example. Then the other types of proxies, besides the points, which is the most performant one, are then the bounding box and then the convex hull, which in my opinion is the best version, or at least for vegetation, it's the best all around. And the last option is the remesh option, with which you have to be a bit careful. And usually I just type the values. I don't drag the slider because it can crash your Blender. Here you also have the adaptivity setting, which basically just removes some of the points. If I enable the wireframe, you can see what is going on. So this is the remeshed tree, but if I turn up the adaptivity, it basically just removes the unneeded points. It merges them. And the last option here is to set a material for the viewport version of your asset, because if you have some grass scattering and if you're using the default points display, those grass assets will just be white and it throws you off a bit. So it's better if you have a prepared material for it. For example, here is the blue material. That's it for the scatter on surface settings. Now I will go over the other two scattering nodes. Settings for the scatter on curve are pretty much the same as those for the scatter on surface. The only part that is different is the scattering. So let's start by adding a curve. I'm using a Bezier curve object here, and I'm drawing on top of this shape. You could also draw just in the 3D space, but then your curves aren't aligned to anything really. First, let's change the asset that is being scattered to the trees asset. If we go in the scatter panel, we can see that we have two scattering modes, curve and curve strip. Here for the curve, we can see that we have a density distance option. This basically just defines how sparse the assets are scattered. The factor setting is the same as the one on the scatter on surface, and the seed setting is also the same. You can influence the scale of the assets besides using this scale option in here. You can also influence it by scaling the curve, which can be done by changing its radius. So here, if I use this tool, you can see that here the radius is really small. Here it's really big, really small, and really small. This comes in handy in scenes where you basically have a foreground element, like a house, and you want to add some background trees, so like this. And maybe you want to taper the scaling of those trees. So maybe in the middle, let's first add a bunch more trees. In the middle, you would want smaller trees, and on the edges, you would want bigger trees. So like this, and imagine there's a house here. So yeah, like this, because sometimes it can be a bit distracting to have also trees here. This is what this scaling is used for in this case. So this is the first option. Let's also show it off inside of the grease pencil object. And now if I draw on this surface and add the scatter on curve modifier, change the asset type to the trees, we can see that the same thing is going on. But now, for example, let me disable this. If I sculpt the thickness, so if I go into the sculpt mode, and if I select the thickness brush, enable this, and when I basically thicken this line, it's the same thing as if I were changing the radius of the curve, because I am changing the radius of the curve. So this is the same thing. Also, if I delete it, yeah, it also just deletes the trees because I'm deleting the curve. So this is this behavior, but I could also change this from curve to curve strip. This basically creates the surface from the curve, and then the assets are scattered on top of that surface. It's also good to use this feature in combination with the auxiliary surface, so I will enable it and select the object plane. Now you can see better results. For now, I will delete this grease pencil object. You get the point. Let's focus on these settings. So if I create a path like this, and if I increase the density, you can clearly see the curve line or the curve strip that is being generated. If I again change the radius, now we're basically influencing the size of the curve strip and not anymore the scale of the assets. So let's say we want more assets here, less assets here, more assets here, less assets here. Like this, we can shape this. Another thing that happens with the curve strip mode is if we draw a circle, so like this, make sure to check this cyclic, and let's decrease the radius. You can see we have a circular strip, but we can check this fill cyclic curves. Cyclic curves means they're connected, and this fills the interior of the curve. You can also, like this, include radius, which basically just expands the curve strip again, because if I disable the fill cyclic curves, you can see the border is here, and if I enable it, the border is again here. If I don't have this enabled, then the border shrinks. This is useful to draw patches of trees like this and like this. It's a really fun tool, in my opinion, but you need to make sure that the curves are actually cyclic. Keep in mind that you can still draw regular strips that aren't cyclic while you have this fill cyclic curves mode turned on. The rest of the settings are the same as in the scatter on surface, like for example this factor and density and minimum distance. But another thing I want to point out is, for example, let's use the rotation boundary alignment. The boundary now, it uses the curve strip boundary. As you can see now, if I draw these curves, I basically generate geometry, and based on that geometry or the boundary edge of that geometry, we are aligning the scattered assets. So if I invert the direction, let's change the amount. We're basically controlling this. So let's draw a straight line here because it's best seen in this example. And if I set it to outside, you can see that all of the trees are pointing towards the boundary. And if I invert it, all of the trees, or almost all of the trees, I'm not sure what's happening in here, are pointing away from the boundary. So that's pretty much it for the scatter on curve. It's basically the same as the scatter on surface, just with curve object types. The last scattering node is the instance on element, which is actually an instancing node. The difference between this node and the other ones was that on the scatter on surface, we have a surface and we scatter a bunch of elements on it. On the scatter on a curve, we have a curve and we scatter a bunch of points on top of that curve. In the instance on element, we have a bunch of elements and we replace those elements with the assets. So it's best to explain it by showing it. If I enable the modifier, we can see that before we had 3 squares and now we have 3 assets. Or actually, if I set up the assets, so let's see, trees, you can see that for each individual element, we are spawning a tree. So if I extrude this, we're actually going to be spawning another tree. Or if I just duplicate this edge, we are going to be spawning a tree along the edge, and the size is defined by the length of the edge. Or if we duplicate this point, you can see that we're basically just spawning a tree on this point. This enables a cool workflow, which is using the hair curves. So let me show it off. Basically, we need a surface. We need to add the curve empty hair. Here we have the hair object, and we want to add the instance on element on it. Yeah, actually this didn't work correctly because I have to target the curves, and it's best to do it by just selecting it here. I will hide these nodes for now, and I will focus on the actual settings. First, let's set up the asset we want to scatter. This is the trees, and now we can begin to draw our curves. So if we spawn a single curve, you can see that you basically spawned a single tree. It's important to keep in mind that when it comes to curves or basically edges, it only uses the first and last point, so we can change this point count to 2 so that we don't spawn too many points unnecessarily. It will work, but it will bloat up your file with too many points. So now I can just place a bunch of trees like this. I can use the density thing. Let's change this shape to 2. Let's enable interpolation. You can see now I'm just basically spawning a bunch of trees. I can move them around. I can make them larger like this or smaller like this. It's basically a way to really precisely place your assets. If you don't want to use the hair curves, you can also, for example, let's disable them for now. You can use a point cloud. It also works on it. So let's just add a geometry node, instance on element, set the asset to the trees. And now you can see that the trees are being scattered on top of these points. Since the points don't have a few of the attributes that we need, for example, they have the scale, which I think that it does get, yeah, it does recognize it, or basically it just translates it. We can use that, but we can't use rotation, which is a bit of a bummer. But we can, for example, let's keep this point and delete all of the rest. Use the auxiliary surface again, select this surface, and now let's select this point, enable face snapping. Now we can place a bunch of trees like that. This is also an option. It's not as good as the hair curves in my opinion, but it's also really nice. Now let's get to the differences in settings. Since there are no scattering settings, the panel is named instance. You basically just have the seed option, and inside of the instance order, you have this manual checkbox. This is useful when, for example, let's place a bunch of trees. The UI is a bit annoying, but let's place a bunch of trees, and I want this tree to have a specific asset on it. Let's enable it. When I randomize the seed, you can see that the trees change, but let's add an attribute. First, we need a boolean with a, let's say, override. Now we will select the actual point, type set attribute and enable it. Now this attribute is stored on that point. If I check this attribute toggle and use this override, and let's enable this back. Now if I change the seed, you can see that the seed only changes on those that don't have this manual override attribute. But I can set a specific index for this tree. For example, I can set it like this, or if maybe I have multiple trees, so let's disable this and set this one also as override. Now all of the other ones are random, but those two are specifically the asset with the index of 0, or the asset with the index of 1, or the asset with the index of 2. But maybe I want this asset with the index of 1 and this asset with the index of 2. I can do that by again adding another attribute. Let's say it asset index. We will use the integer data type like this. And now I'm not sure what I said I wanted, but let's set the index for this one at 0, set attribute 0 and press enter. And now for this one, set attribute, set index at 1. Now when I enable this modifier again and pick the actual attribute asset index, now you can see that this scattering is random for these assets, but we have consistency in the determining of the asset index for those two. This option is important because I'm not sure if you have noticed it yet, but let's say I delete this asset. You can see that the indices actually changed. Basically, this is the function of how to use the manual and the index settings inside of the instance order. Yeah. That's the explanation for the instance on elements node. It's basically just meant to be used with the hair curves, since you can really easily add assets and move them around and scale them. And that's it for the scattering nodes. Now let's go on to the masking nodes. The next node I will go over is the proximity mask node. I actually created this node first before any other of the scattering nodes. This node creates a mask based on target geometry. To understand it better, I will visualize its output. As we can see, the output is currently 0. Everything is black. That is because we have no input target geometry selected. If you go under the target and select an actual object, for example this torus, we can already see the mask. As in some other nodes, you can see that we can either choose between the data block or the geometry. The geometry option is only available inside of the node editor, and it's not implemented inside of the modifiers. If we wanted to sample multiple objects, we can do that by using a collection. So for example, I have all of these objects inside of the collection 1. So I will just select it, and now we can see that there is a gradient coming from all of the objects. But we can also see this strange line. So for now, I will skip all of these other settings and go straight into the sampling settings. If I enable the sample inputs individually, I will fix this artifact. What this option does is basically, instead of checking the distance from all of the objects at once, it goes over each object and adds up the distances. The second option is this width option. This basically defines the distance gradient. So if we have it at half a meter, the gradient is only half a meter long. If we have it further, the gradient reaches out further. The next option is the mid-level. This is similar to the mid-level that you can see in the displacement node that comes with Blender. So if I set it to 1, you can now see that this distance is being calculated from inside of the object. So for example, if I set the width lower, we can see that the gradient is 20 centimeters long from inside of the surface. Let's set it back to 0. If we want the gradient to go both outside of the geometry and inside of the geometry, we just set the mid-level to 0.5, as you can see now. Now the width is split up into the outside part of the geometry and inside part of the geometry. This offset option might look similar to the width option, but it's actually something totally different. Right now we can see that the gradient is half a meter long. If I offset it, we can see that the gradient itself is still half a meter long, but we just added some padding. The result wouldn't be the same if we change the width to 1 meter. As you can see here, there's a gradual fall off, as in the other example, like I had before. We can see that this is a constant value and then the fall off happens. Another cool option is the smoothing option. As you can see, we can smooth out the gradients together. This acts similar to the metaballs. We can then also invert the gradient, which just basically inverts the gradient at the end of all the processing. Now that I have explained all of those options, let's go over the self option. This option might seem a bit strange, but I'll explain it on a different example. I have now added the scatter on surface geometry node before the proximity node, and I named the output of the scatter on surface to forest. Now if I add the named attribute inside of the node editor and set it to forest, if I now connect it to the second selection, we can see the effect. Now we can generate a mask based on previously scattered assets. Now we can go over the instances settings. In order to keep up the performance, we can use proxy geometry instead of the actual instance assets. By default, it is set to point. We can also use the centered point, which means that the point just moves to the center of the scattered asset instead of its origin. There is also a bounding box option, which you can see that the gradient becomes a bit more boxy. And lastly, there's the convex hull option. When we use the point proxy geometry, we can either compute the radius of the point or actually set it. So for example, here each of the assets have the same radius, which we can define, or we can use a computed radius based on their size, and we can offset that radius. For the computation of the point radius, we can either look at all of the axes of the asset, only the x and y, or only the z-axis. Besides regular meshes, point clouds, and instances, the proximity mask also supports the different curve types. So for example, I will show off how you can use a Bezier curve. Like this, you can just draw the shape, but you have to keep in mind that the default radius for the curves is set to 1 meter, so you need to scale them down. I'm using the Alt-S shortcut here, and then all of the other settings are basically the same. Besides the Bezier curves, you can, or other types of curves, you can also use grease pencil, which I will demonstrate right now. You just need to go into the draw mode, make sure the drawing is set to the surface, and now if I draw, you can basically see what I'm drawing. And if I set the mid-level to 1, if I change the radius, you can now see that the stroke thickness matches the radius of the brush, which is also quite a lot of fun to do. You can basically then draw these wacky masks and maybe offset them, smooth them, or whatever. The proximity mask is really powerful and really fun. You just need a lot of geometry on the source geometry to actually store the data. The last node I will go over is the image texture mask node. This node is used to just store the image information as a mask. So for example, I have a basic texture here. I will first visualize the output so we can see what's going on. At first there's nothing because we haven't set up the correct texture. Then we also need to set up the UV map. And as you can already see, by default it outputs the red channel. I can change that to the green channel, to the blue channel, or the alpha. I can also invert the results, and I can change which frame of the image texture sequence is used if we have multiple frames, and we can also set the extrapolation type. This node is mostly intended to be used with terrain generation software such as Houdini, where you can basically export where all of the trees in your terrain are, or export where the grass is. And then you basically use that texture to generate a mask, and based on that mask you drive the scatter on surface geometry. And this is basically it for the quick scatter introduction. I hope that the video wasn't too long for you, and I hope that I explained the options and the nodes and what they do as best as possible. I tried my best, but since there's a lot of settings, I hope I didn't miss anything. If you have any problems, feel free to comment down below or direct message me so I can clear up any confusion. Thank you for watching and goodbye.